notes, your unit circle, and a whiteboard. Someone give me the basics of what we talked about on Tuesday, last time I saw you. So again, notes from Tuesday, unit circle, along with a whiteboard, marker, eraser, and you will need a calculator as well. You need a calculator as well. So you got a bunch of stuff going on your desk right now. Give you about 20 or 30 seconds to get all that stuff ready. Yep, your 8.1 notes. Okay, so someone tell me what we talked about. Silence, all right, great. Trig equations, and why are solving these trig equations different from when we solved trig equations last chapter? What's different? So we get the trig function by itself. Okay, but before, we solved for every possible answer, right? We said, well, if I'm on the unit circle, and I wanted for, if I asked for, hey, where is the sign equal to -1? Point in the direction, up, down, left, or right, where the sign is -1 in the unit circle. Okay, most people are pointing down, because sign is the y value. Y would be going -1, would be going down 1, I'd be right here. In radians, where is that? 3 pi over 2, very good, Caleb. So at 3 pi over 2. Now, before though, we said, well, we want every possible answer. So what do we have to add on to 3 pi over 2? Plus 2 pi n. Why is it 2 pi and why is it n, Jack?
2 pi is 1 rotation and is number.
Very good. Jack says, well, the 3 pi over 2 tells me I'm going to start at 0. I'm going to go counterclockwise and end up here. And then the 2 pi, well, that means, well, if you go one time around the circle, you'll end up at these exact same spots. And the n, like Jack said, is the number of times you go around the circle. Now, we aren't having this 2 pi n anymore. This is going away. Why are we not having that? What do the directions say, for example, 1 yesterday? Solve for, what does it say? So we were in degrees, and this is in radians. It's the same concept. So on the back side, we did radians yesterday, and the front side was degrees. But what they do is they're giving us an interval. They're saying, hey, I don't care about how many times you can go around. I only care about 1 revolution around the circle right now. Okay? We also talked about getting our trig functions by themselves. So just like if you had x plus 7 equals 10, how do you get x by itself? Yeah, that's easy. That's algebra 1. Subtract 7, subtract 7. What's that called when you're adding? To get rid of adding, you subtract. 2 words. Inverse operations. So just like inverse operations, to get rid of adding, we did the inverse of adding. To get rid of a cosine, if we had cosine of x, we want to get x by itself. How do you get rid of cosine? Inverse cosine. So we need the inverse cosine, we got to do it to both sides, whatever it looks like. Is this all ringing a bell from Tuesday?
Yes.
Okay, I want you guys to write this down. And right now we are in, actually I'm not going to tell you what you're in, I'm going to give you the directions of the interval. So I'm going to tell you, hey, I want the answer to be between blank and blank. You got to tell me then, are we in degree and radians based off of that? Okay? So I'm going to say, let's go 1 equals 1 plus the cotangent of theta. And your interval is 0 is less than or equal to theta is less than or equal to 360. So I want you to solve each equation, solve for theta, but your theta is between 0 and 360. Yeah, if your markers are dying, guys, there's a whole box back by the calculators back there. I think Mr. Zwig kind of jumbled them up. Some of them are dying, so if they suck, just chuck them. What was that? So, what's in the green highlighted box, Caleb? That's the interval I want your answer in. This is the question, that's the answer I want your, excuse me. In the box is the interval I want your answer in. This is the question. to solve for theta. 0 equals 1 plus cotangent of theta. So if you remember from yesterday, the first step is, hey, I should get that trig function by itself. Then after you get it by itself, we are used to working with sine and cosine. Now tangent and cotangent are a little bit different. So if you are given cosecant or secant, after that trig function is by itself, you should switch it to the ones that we are used to working with. Great. I want Lee May to get us started. She killed it.
I think this is wrong.
Let me see your calculator quick. Okay, so remember when I said that like we're not used to working with secant and cosecant, those are kind of goofy ones. Tangent and cotangent are nice because it's x over y and y over x. So we don't gotta switch cotangent and tangent. We only gotta switch secant and cosecant. So that's kind of where you messed up here.
And the inverse of cotangent, tangent.
Okay, guys, let's look at this one, and then I'll answer questions if people have it after that, because I think a lot of people made the same mistake. I think I'll be able to answer the same question by going through it. So Lee May, how did you start?
I started by writing x over y because that's what the tangent is. And then I was looking in a circle for where x over y would equal -1.
So she said cotangent is x over y, that's how she started. But then, even before that, when you had this problem, what did you do first?
Oh, I subtracted it.
Yeah, so she says we gotta start writing a trig function by itself, -1, -1. So we get -1 equals the cotangent of theta. Now, this one's a little goofy because it's not really doing what we talked about when we started. But Lee May said, well, cotangent, that's just x over y. So she says, well, on my unit circle, where is x over y equal to -1? Well, Lee May, if you have a fraction that equals -1, what is that fraction gonna look like?
A positive and a negative is the same number.
So same number, one of them is positive and one of them is negative. So going off of that, which two quadrants should you be looking in? Which two quadrants are your possibilities that have one positive and one negative? 2 and 4. So you know you should even look in quadrant 1 and quadrant 3. Why? Because if we have x divided by y in quadrant 1, it would be a positive. A positive divided by a positive gives you a positive. In quadrant 3, a negative divided by a negative gives you a positive as well. So Lee May says, well, I looked at my unit circle and I found at where in quadrant 2?
135 degrees.
At 135 degrees, so right here, 135 degrees. And she said, I also looked in quadrant 4, and in quadrant 4, where is x over y, where is the tangent and the sine, so not the tangent, the cosine and the sine, the same number but different signs? At 315 degrees. So your answer then is 135 degrees and 315 degrees. Okay, I have a question for you now. Let's say you brought your unit circle home and your dog ate a quarter of it. He bit off the whole fourth quadrant down here. You don't have that. You do have this quadrant, this quadrant, and this quadrant though. So you do not know what your angle in quadrant 4 is. Is there a way using quadrant 2 and knowing that 135, the cotangent of 135 is -1, is there a way that we can use that to figure out where in quadrant 4 we would also get a cotangent of -1? Just look. What do you mean by that, Caleb? But your dog ate this though, he doesn't have it. You don't have that.
Well, I would do either
Aaron.
360 minus 45.
Okay, so you're both kind of on the same track. A owner used the math word though. I'm gonna go with what he said. What did you say, A owner? The reference angle. So what does that mean? What is a reference angle? So in kind of like basic terms, it's getting to the x-axis. So a owner says, well, 135 plus what number? 135 plus what? Or I just erased it. 1 second, I gotta undo that. Okay, so he says 135 plus 45 gets you to 180. So same concept in quadrant 4, instead of going up 180, now which way do you go? Down 180. So a owner says, well, if you go down 180, that would be negative 45 degrees. But it's negative 45 degrees. Again, the reference angle was 45 here, so it's going to be 45 here as well. This negative 45 degrees, does that satisfy my, going to constrain my restriction up here? It's negative 45 between 0 and 360? No, so how do you figure out what negative 45 is? There's two ways to do this, two ways to think about it. Add 360, what's that called? Well, when you add a revolution, these angles are called coterminal. So we're going to find the coterminal angle with negative 45. Lee May says, well, just plus 360. What's negative 45 plus 360? Boom, 315. So again, when we have tangent and cotangent, we just look at, hey, where's x and y? Where does that equal whatever I have in terms of the problem?
How'd you know it's negative 45 instead of just regular?
Because when we go around the unit circle, we go counterclockwise. So this would be positive 45, so you keep going. But now, if I go from here to here, I'm going down. So that this is the same as 360 minus 45. Make sense? Okay, let's try another one.